Hello everyone, I hope you're doing well and welcome to the platform of Coaches. So, this is your mentor Ansh and today we're going to be solving the problem Friend Zone Pari, whose difficulty level is simple to easy and there are no prerequisites required whatsoever to solve this particular problem. So let's move on to the problem statement. Okay, so let us glance through the problem statement. Pari's girlfriend loves words which contains vowels only. The player game where Pari would get a string from her and he needs to find out the length of longest substring containing vowels only. If he fails, then his girlfriend would friend zone him. Help Pari to impress his girlfriend and not get friend zone. So basically in this question we are told that we are given a string S and in that particular string we have to find the longest substring which only contains vowels. Now firstly, let us understand what a substring is. So consider any string, say I take A, B, C, D, E. So my substring is any part of the string which occurs in a contiguous sequence. So example, my AB, BC, AB is a substring, my BCD is a substring, my A, AB, ABC, ABCD, ABCDE, like any part of the string which I can take together becomes a substring. My BCD, my DE is a substring, and so on. There are n into n plus 1 by 2 possibilities for the substrings. Okay, so now since we got to understand the substring, our question says that we have to find a substring which only contains vowels, and out of all those possible substrings we have to find the length of the longest substring containing vowels. Longest substring containing vowels. Okay. Yeah. So this is a question. So now let's move on to the approach how to solve this kind of problems. Let's try to understand the approach for the following question. Now, firstly, to understand the approach, let's just discuss the sample test case first. So I have my sample test case, my A, B, C, A, C. So, as I told you, a substring is any part of the string which is occurring contiguously. So here, my AA is a substring which contains only vowels, and here my A is a substring which only contains vowel. So this is of length 1 and this is of length 2. Hence, my 2 is the answer. Now, consider any particular string. Say I have my string A, E, I, B, B, A, B, E, P, E. Now, as you can see, this is my substring which contains of 4 length and only vowels. This becomes my string which consists of 2 length. This is my another substring which consists of 1 length. And this is my substring which consists of 3 length. And the maximum one is 4. So the answer for this particular string will be 4. Now, so as you know, how could we write an algorithm for this type of thing? So what we could do is we could initialize a counter and which will kept the initial value of 0. Now and we could keep our answer variable which is initially 0, because if there is no substring then my length is by default 0. So what I'll do, whenever I encounter a vowel, I'll increment this counter by 1. So as I encountered A, my value of C becomes 1. As I encountered E, it becomes 2. As I encountered I, so another vowel, so it becomes 3. And here it becomes 4. But as soon as I encounter a non-vowel, then I will first take the maximum of my current value and the required value, which is 4. And then now here my counter is 4. And first I'll just take the maximum of both of this. And then I'll reinitialize my value of counter of 0. So what we are doing, for every contiguous vowel, we are incrementing the counter, and as soon as we encounter a break, which is a non-vowel or a consonant, we store the word, we compare with our answer, we store the maximum of those since we want to find the maximum length of that substring, and then we re-initialize that counter. So again we have a non-vowel, so my counter will be remain 0. And again we could just take maximum of 4 and 0, which is again 4. So then for A and A, my counter will get incremented to 1 and my counter will get incremented to 2. And then once I again encounter my non-vowel, then my counter will compare with get 2, so maximum of 4, and 2 will still remain as 4. And similarly, it will again the counter will get 1, and here the counter will be 1, 2, and 3. So after the end of the string, you have to keep in one thing. Like since there are like after the end of the string, you have to check. So here, consider the case if there were 5 or 6 C's in that. So once you came out at the end, your value of counter would have been equal to 6. But now you don't have any non-vowel outside. So after traversing through the entire string, you have to keep one last condition that checks the value of counter with the answer. So you have to again repeat the step. So in the last step, I take my answer as maximum of 4, 6. So that times my answer is equal to 6. So yeah, in the last step, you have to check, like after the iteration, you once have to check the value of counter with answer, and then you're completely safe. So yeah, this is the way we can traverse through the entire string using the counter variable and compare it with answer to get the length of largest maximum substring which only contains vowels in the time complexity of O of n or O of length of string. Since we simply traverse the string, the time complexity of O of n. So yeah, let's just see how to code this particular thing. Okay, now let's try to understand the code for this particular problem. As I discussed, we first take input of the string, initialize its length, and we keep two variables, one as answer and one as counter. Now if I encounter a vowel, I increment the counter as 1. Otherwise, if I encounter a non-vowel, as I said, I take the maximum of answer and counter and I reinitialize my counter as 0. And this I traverse for the entire loop. But in the final step, as I said in the approach section, I again compare my answer with counter. And then we are safe and hence we can print the final answer. So let me just run this particular case in our code to see that everything is working properly or not. So as you can see, we got 2 as a required answer. Yeah. Now let us submit our particular code and see whether this works or not. Okay. So as you can see, this particular code works. And let me show you the Python code as this as well. So yeah, we do the same thing. We take the input and we just kind of compare the counter and we get a final answer. The entire same thing in Python as well. Okay, so now I would like to discuss what all type of mistakes could people make in this type of problem. So if the logic and approach is clear, I don't think there's any syntactical error or any kind of thing that people could make in this. So only one thing what people could do is, since in the question we are told to calculate all the substrings, so people could use a brute force algorithm and traverse calculate each and every substring and check whether it is a vowel substring or not and take the maximum of all those, like whatever length we get by actually brute forcing and converting the substring. But that algorithm's time complexity will be big O of n square and it will give a time limit extended error according to the constraints of the question. So yeah, what we have to do is we have to smartly do the question in time complexity of big O of n, and that's what exactly we did. So I hope you liked the video. Please like, share and subscribe to our channel. Thank you.